I've got jars, I've got liquids, I got stuff, I even have a stick. We're going to use it all to explore the science of moment of inertia. What's inertia?
An object's resistance to change in motion.
So an object at rest wants to stay at rest. An object in motion, uniform motion, wants to stay in that uniform motion. Moment of inertia is about rotating objects, okay? Things that spin. And a moment of inertia is resistance to change in rolling motion.
Okay.
So, we're going to explore that by rolling jars. We're going to go over to the racing ramp, and we're going to start with a couple of cylinders. Okay, Dan, you have a jar. Is it full?
It is full with salt.
Yes, actually it's sugar. Nevertheless, but it's jammed. Does it move around?
It's solid.
It's a solid cylinder. Leanna, what's in your cylinder there?
Nothing.
Nothing. You've got an empty
Empty.
jar. Which one of the jars is going to start to roll faster and reach the bottom first?
Empty one?
No.
Okay, empty.
The full one. It has more
full.
mass, more inertia.
Ooh, but inertia is resistance to motion. If you have more inertia, you have greater resistance to motion.
I'm gonna stick with the empty one because it's mine.
Only one way to find out, right?
Let's do it.
Okay, let's do it.
Do it.
Somebody's gonna buy me lunch. Here we
I
go.
need a 3, 2, 1, a 3, 2, 1, go.
3, 2, 1, go! I win!
Who won the race?
I did. The sugar.
The solid jar won the race, right? What happened to your hollow jar?
Didn't get very far.
It got smoked. It got
Yeah.
left behind. Now, the question is why? In a rolling object, it's about where the mass is distributed. If the mass is distributed and kept close to the center of rotation, to the axis of rotation, it will start to rotate faster. Where's the mass in your jar?
All around the outside.
It's on the outside. The mass in this jar is evenly distributed around the axis of rotation. The mass in the hollow jar is distributed well away from the axis of rotation. If the mass is far away from the axis, it's going to accelerate more slowly. It's going to have a higher moment of inertia. Now for the second experiment, we're going to keep the hollow jar. You have it there? And we're going to add a jar partially filled with water. If we race those two, who's going to win?
What do you think, Lee?
Why don't you can go first, Dan. What do you think?
I'm gonna go with the empty jar once again.
The one with the water.
Going with the water. Okay, Andres' water jar. What do you think, Jennifer?
Empty one.
Water over here, empty jar here.
3, 2,
1,
1,
go!
go!
What the? Nothing. I thought...
So when we add a little bit of water to this, we actually bring mass closer to the axis of rotation, and that's going to reduce its moment of inertia, and it'll start to accelerate a little bit faster. So, experiment number 3, and now we're bringing in another liquid. We're putting water up against
Dad, pay
corn
attention,
syrup.
okay?
Hold them up together so we can see how much is in each. They're about the same amount, same contents.
Yeah.
So corn syrup kind of heavy?
Yeah, it's pretty heavy.
Yeah, so remember it's all about mass closer to the axis of rotation, right?
Yeah.
Which one of these is going to win the race to the bottom?
This one.
Water.
1 vote for the water, 2 votes for the corn syrup. Okay, we have a competition here. Give me a 3, 2, 1, go.
3,
2,
2,
1, go!
3, 2, 1, go! Hey!
Oh, what's going on there? It's not even in the game.
Hasn't even moved.
Whoa, corn syrup, get in the game. We introduced one more important factor here that affects the rate of rotation in a system like this. When this jar is rotating, there's a little bit of friction between the water and the glass, but not very much. But in this case,
Thicker?
it's thicker, it's viscous, and there's a lot of friction between the syrup and the glass. So to wrap up, in those 3 different races, we saw several different things. A solid cylinder has a smaller moment of inertia than a hollow cylinder, so it's going to start to rotate. It will accelerate in its rotation faster. And that's because the mass is closer to the axis of rotation. But then when you add the corn syrup, well, everything slows down because the viscosity and the friction just mess up the rotation totally. And you end up with a cylinder that doesn't really want to go anywhere.